Alright, let's look at some examples now and how we can identify whether a function is a probability density function. Okay, it says sketch the graph of each of the following functions and state whether each function is a probability density function. So let's sketch this first one. We're looking for f of x is 2 times x take 1 between 1 and 2, and we can see that that's a linear graph. Okay, and we're going between 1 and 2. We get our scale here, 1, 2, so we have 0, 1, 2, that's our x-axis, that's our y-axis, and we know we've got y equals 2 times x take 1, and in order to draw a straight line, we need 2 points, so let's say when x equals 1, we have that y is equal to 0, so we have a point there at 1 and 0, and when x equals 2, y equals 2, and we have a point there at 2 and 2. Alright, so let's have the points. I've got this long enough. Going with that scale there. So that's 1, that's 2. We have a point there, and we have a point there. So let's draw this PDF, or let's draw this function and decide whether this is a PDF. Now, there are 2 things that have to occur for a PDF. Number 1, it has to be positive, and number 2, our integral has to be equal to 1. So the first thing we're going to say is f of x greater than 0, and we can, or greater than or equal to 0, and we can say yes it is, it's above our x-axis. Okay, and is our integral from 1 to 2 of 2x take 1 dx equal to 1. That's our other condition. Okay, so let's do that integral. So we have the integral from 1 to 2 of 2x take 2 dx, and that's going to be equal to 2x squared over 2 minus 2x between 1 and 2, and that's going to be equal to 4 take 4 minus 1 take 2, and that's going to be equal to 1. So therefore, this is a probability density function. Alright, let's have a look at the second one. That one is f of x is 0.5 between 2 and 4 and 0 elsewhere. Alright, now again, y equals 0.5 is just a horizontal line, so we can graph that quite easily. Draw axes, and we're going up to 4. So we have 1, 2, 3, 4, and oops, that would be 1, 0.5. Alright, so 1, 2, 3, 4, x and y, and we know that we're going from 2 to 4, and we've got closed in dots there, and we are drawing our line, and we know that this function, let's try to get some nice straight lines there, is going to be 0 everywhere else and 0.5 between 2 and 4. So that's going to be our area. Alrighty. So we need to decide, is this thing a PDF? So we're asking, is f of x greater than or equal to 0? And yes, it's above the x-axis. It is greater than or equal to 0. And our second question is the integral from 2 to 4 of 0.5 dx equal to 1. So let's test and see. So we have our integral from 2 to 4 of 0.5 dx, which is equal to 0.5x from 2 to 4, and that value is 2 take 1, which is equal to 1. So therefore, this is a probability density function. Alright, let's have a look at the third example. That is y equals 2e to the negative x from 0 to 2 and 0 elsewhere. Alright, and you can go over the page for that. There's a bit more space there. So we know that this is an exponential decay model. And get my points there while I've got this thing at 90 degrees. Oops. This takes great skill. Okay. And we're interested in 0 to 2. Let's give ourselves a bit of a scale there. There's 1, there's 2. So 1, 2, 0, 1, 2. There's our y-axis, there's our x-axis. And we know that we're interested from 0 to 2. So when x equals 0, we get that y equals 2, so we have a point there, 0 and 2. And when x equals 2, y is equal to 2e to the negative 2, which is approximately equal to 0.27. So we're going to have a point there of 2 and 0.27. That just gives us a bit of a point or an idea of what this graph looks like. So we've got that point there, and we know it's an exponential decay. So we've got something that looks like that. That's our point there of 2 and 0.27. And this is our area under the curve. Alright, now we need to decide, is this thing a probability density function? So our first question is f of x greater than or equal to 0, and we can say yes it is. It's above our x-axis. Okay, our next question is the integral from 0 to 2 of 2e to the negative x dx equal to 1. Okay, let's check. 0 to 2 of 2e to the negative x dx, and that's going to be our integral is negative 2e to the negative x from 0 to 2. And that will give us negative 2e to the negative 2 minus negative 2e to the 0. And that's going to be equal to negative 2 over e squared plus 2. And that is most definitely not equal to 1. So therefore, this is not a PDF. But we could also figure out which value we could set as our limit in order for it to be a PDF. So let's ask ourselves, what would be the limit for this to be a PDF? Okay, so let's do that. Let's see, we have an integral from 0 to k of 2e to the negative x dx has to now equal 1. And we're wanting to find the value of k. So we can use our calculator. we can just use our solve n function there. Solve n, integral from 0 to x of 2e to the negative x dx equals 1, and it will spit out a value of k is approximately 0.69315. Alright, we're going to stop there for today. I'd like you to do exercise 11.2, question 5 and 6.